What we're going to demonstrate is fluorescence. Fluorescence occurs when you radiate a substance with high energy radiation like ultraviolet light, and then that substance will emit a wavelength lower than the radiation of UV light. What we've got here is a set of UV tubes, and we'll see what happens when I turn them on. What we've got here is 5 fluorescent tubes. I'll turn on the first one. So this fluorescent tube, like all the others, is filled with mercury vapour. So when I turn on the voltage, the mercury vapour gets excited by the high voltage and starts emitting light in the ultraviolet and violet range. So the glass is fairly thick on the tube, so it's only allowing violet light to come out. So it's got no coating on it. I'll turn on the second tube. It's like the first tube, but only half it's coated with white phosphorus material. So this side of the tube is like the top here. We've got a mercury ultraviolet plasma vapour happening inside here. So it excites the white phosphor. The white phosphor then emits lights. The white phosphor then emits wavelengths of all visible colours, so therefore it appears white. Here we've got a red fluoro tube. It's like the second tube here, but it's fully coated with red phosphor material, so therefore it's got a ultraviolet violet plasma happening inside it, but since it's fully coated, we can only see red light being emitted because it's been coated fully. Below this one we've got a yellow fluorescent tube. This has got the yellow phosphor coating on the inside like the other tubes, 2 tubes here, but it's only allowing yellow light to be emitted, so it's been chosen that this phosphor material has been coated inside with yellow phosphor material, so when we turn on the light, the UV radiation excites the inside and the phosphor only emits yellow wavelengths of light coming out, as we see here. Now we'll turn the top one off. Here we've got a bottom tube here. This tube is thinner than the other ones. It's got thin glass tubing, so it's allowing UV light to escape. It's got a coating which only allows the UV light to escape, and as you can see below, you've got all these minerals here glowing because they've been excited by UV light. These paper stars have been impregnated with fluorescent material, so they're emitting wavelengths of green, red and orange. We've got blue Omo here, which is a washing detergent for clothes. So it's got grains of phosphor in it, and this phosphor will attach itself to its fibres of your clothing. So when you shine light, UV light on your clothing, it'll glow. So when you walk outside in the sunlight, your clothes will glow, or under UV lights or incandescent lights which emit a bit of UV radiation. What we've got here is some stars, plastic stars. They've been impregnated with fluorescent material. So if we turn off the lights, you can still see the stars glowing. They're actually phosphorescent material. They're like fluorescent material, but they just got a longer delay in emitting wavelengths. Because as you can see, we turn on the UV light, all the minerals and paper and blue Omo and stars are fluorescing. As soon as I turn off the UV light, they stop fluorescing, except these stars here. They're actually phosphorescing, so it's like fluorescence, but there's a time delay. It just keeps fluorescing for a lot longer than the just purely fluorescing material. So that's. This is a close-up of the fluorescent tubes. As you can see, the top tube is purely glass on the outside. The second tube is half glass, and the second half is coated with fluorescent white phosphor. This tube is fully coated with red phosphor. This one here is purely coated with yellow phosphor, and the bottom tube here is thinner glass. It's got some sort of coating, but it allows ultraviolet light to come out in greater quantity than the top four fluorescent tubes. I'll turn off the lights now. As you can see, the top one is just an ultraviolet violet plasma inside the tube. Ultraviolet that excites the phosphor coatings on the inside of the fluorescent tubes below. As you can see, white light, red light, yellow light, and the bottom one is just allowing UV radiation. As you can see all these minerals glowing. Depending on what type of material I got on, they'll glow a different colour. The paper stars, they're being impregnated with fluorescent minerals. The blue omo, that's got phosphor particles in it too, so that glows a whitish colour, like in the second fluorescent tube. It's letting off a bluish, whitish colour, and when you see the stars, they're fluorescing a green colour. Alright, we turn off you can see the fluorescent materials have stopped glowing except for the green plastic stars here. They're actually phosphorescent material. It's just the same as fluorescent material, but there's a time delay when they still keep fluorescing for seconds afterwards. As you can see, turn on the UV, all the fluorescent materials start glowing immediately. The phosphorescence takes a bit longer to get going, but it's fully glowing now. Turn it off and you can see the fluorescent material is slowly fading away, but